So this is the menu that we have before lunch. We are going to introduce what is Zeitwerk, the motivation that I had to work on this. Then we are going to see how Rails autoloads or has autoloaded since the beginning, to compare that with the new solution and how is that integrated in Rails 6, because this is going to be the new autoloader by default in Rails 6. All right, so what is Zeitwerk? It is a gem that provides autoloading, eager loading, reloading of code, and very important, it has no dependencies, so Ruby is enough to solve these problems. And very important as well, it has been designed to work with any Ruby project. So you might have heard of it maybe related to Rails 6, but it is an independent gem. It has been designed to be able to work with any Ruby project, in particular gems, your own private projects. It can be used by other web frameworks, so it's totally generic in that sense, all right? Okay, let's see first how do we use this thing, and after that, we are going to get a little bit more deeper. So the premise to work with Zeitwerk is that you have a project structure where file names match constant paths. That's a standard in Rails, okay? So it's like a very conventional project structure, I would say. So for instance, if we have user.rb, that should define the user constant, right? User underscore profile should define user profile. And if you have HTML parser, the default constant name expected from that file would be HTML parser with lowercase in those 3 letters. But if you prefer to have HTML like an acronym, you can define, there's a way to do that. Okay? You can define a custom inflector for your loader that says, hey, everything by default, I delegate to super or whatever, you know. But in the case of HTML, please do HTML in uppercase. There's an inflector that is super, super simple and deterministic. Different gems or different loaders have independent inflectors. There's no way that one can interfere with the other one. They are deterministic, and you have control about the way the files in your project are going to be inflected. Then, also very conventional, namespaces correspond to directories, all right? So in this case, for instance, we have, let's say, a hotel class in hotel.rb, and then we have a module within hotel class where we have organized everything related to pricing, okay? So you just have a hotel directory, and hotel/pricing is expected to define hotel : pricing, all right? I call these explicit namespaces because we have also support for implicit namespaces, which is something that Rails has had since the beginning, which is that if you are using a directory just as a namespace, for instance here, admin role, but admin is not a module with stuff in it, okay? It's just playing the role of a namespace. You do not need to define admin.rb, okay, defining module admin n. Okay, you do not need to do that. You do not need to do that in Rails, and you are not going to need to do that also if using Zeitwerk. All right. So basic usage is very simple. You just instantiate a loader. You say which are the root directories of your project. Like in Rails, that is going to be the Autoload paths. In Ruby gem is going to be lib. That's it. And then you call setup and done. You are ready to do anything. In the case of gems, since there is a common pattern for gems and projects that technically are not gems, you do not need a gem spec, but that they have a structure similar to gems. So this is just a shortcut to push lib as the only root directory of the project, which is very common, right? And then also in gems, version.rb by convention is a constant where all the letters are in uppercase. So this thing gives you also an inflector that has that special rule for version.rb. But it's just a shortcut. So it is documented, and you do not need to use this in a gem if you have other needs. You can just instantiate a standard, use the previous API, and that's it, all right? Eager loading is this thing. And the first call is an instance method. It's showing an instance method. The second one is interesting. It is a class method in Zeitwerk loader. It says eager load all. So the point of this one is Zeitwerk keeps a registry of all the loaders that have been instantiated. Okay. So in a web service, like in a Rails application, or a daemon of Vue or whatever, you know. Oftentimes it's convenient in production to load as much code as possible on boot, okay? So if you are in a Rails application and there are 10 gems in your dependencies that are using Zeitwerk, Rails calls this method, okay, to give you a concrete example. And not only is your Rails application going to be eager loaded, but all the projects that are managed by Zeitwerk, their independent loaders are going to eager load all of them, all right? So you get all of that, all the benefit in the main process. Indeed, you can even have your Rails application not using Zeitwerk, because you can still use the classic autoloader with Rails 6 if you want. But even if the application itself is not using Zeitwerk, the integration that we have written in Rails 6 is going to call this method in case you have dependencies that are using Zeitwerk, all right? By the way, in Rails 6, none of this API, you do not need to use this API, because in Rails 6 there's an integration that uses this API for you. So your interface in Rails 6 is still config.autoload paths, config.cache classes. That's the same interface that you were using to tweak these things is the one that you're going to use. And the integration is the one responsible for converting those standard parameters in Rails to the API of Zeitwerk, all right? In order to reload, you have to opt in, okay? And this has two purposes. One is to acknowledge at the API level that reloading indeed is one of several possible use cases for this gem. So in general, a gem that is just a regular library does not need to reload, right? Because you have a gem, and when you change something, you maybe run the test suite, but you do not have any service running, okay? So in many use cases that at least I envision for the future, reloading is not going to be used. You are going to autoload or eager load in those gems. But reloading is something that is going to be useful for things that are running, like web applications. So by acknowledging this, we are able to be also more performant for the default case, which is not reloading, because reloading needs to keep some metadata, no big deal, but some metadata that we can save. So for the majority of use cases, we save that, okay? And if you are in a web framework, and note that this is, in addition, normally used only on development. So the combination is, I am developing a service in development mode, okay? For the rest of the modes, I am not going to reload either. So if you see it in that perspective, it's a corner case, maybe, from the API reloading. So that reflects that, okay? All right. Why did I work on that? So three things. My initial motivation was the third one. So the Rails autoloader has some gotchas. It has worked very well for many years, and it has been very helpful, but there are some gotchas that are intrinsic to the technique that it uses, and I wanted to improve that in some way. Then I started to work on this, and I realized that I could also target two pain points of mine, at least, two personal pain points, which are that requires in arbitrary Ruby projects, typically a brittle, and a sense of lack of dryness that I have sometimes. So for instance, my projects normally follow these conventions, okay? So if I have to use the user class, I have to require user. And for hotel, I have to require hotel. I have a personal sense that I'm repeating myself all the time. I am using the constant and then just lowercase everything in require, all right? I am duplicating all this information. If we had like a good convention, maybe we could automate this. So that's a personal feeling for the people writing requires. It's fine, perfect, you know, but this was a pain point of me. I wanted to work on that. So why requires brittle? I am sure you have found this in any Ruby project, except maybe a trivial Ruby project, but in any Ruby project, it's very easy to forget requires. So for instance, we have here an example, class airplane that includes locatable. That is not going to fly because name error, I don't know this constant, okay? So you have to put a require for that to work. But the problem is that requires have a global effect, as you know, okay? And the consequence of that, I'm sure you have faced this before, is that you could have the original source code without the require, and this could work. This could work. Because if in the code path, someone else required that file locatable, then when you arrive here, since the constant or the module is you know, in the state of the process of the interpreter knows that module is already loaded, so it works. And the problem is that when you hit a different code path, maybe in production, then you get an exception. So I've spent a good deal of hours in the Rails code base, sometimes grepping and looking for missing requires. Okay, so yeah, I don't know. This is brittle. I just prefer not to do this, if possible. So Zeitwerk. All right. This is NanoC, which is an static site generator. NanoC, instead of doing like cherry picking requires, it did something that sometimes Ruby projects also do, which is in the entry point of the gem, it has all this list of requires. Okay, this is conceptually is like eager loading, correct? So this also has a cost. It has a cost because every time you add a file to the project, you have to remember to go here and add the file to this list. Also, this list has to be kept ordered. And you may, depending on refactors or something like that, you may need to reorder this because if you have constants at the top level or class level, they are going to, you're going to be able to resolve them when the file is eager loaded. So they have to be eager loaded before. So you have to maintain this by hand, okay? So NanoC is now using Zeitwerk, everything it's all is deleted, okay? So this was all delete, it calls eager load, done. So that's the point. You can streamline your programming knowing that your classes and modules are just available everywhere. That's it, you know? Forget about requires if you want. So now we are going to see how Rails autoloads, and to understand that and to understand the limitations of the technique of Rails, we are going just to do a quick constant refresher to have the concepts, you know, just fresh in mind and be able to follow with the slides. So, you know, constants, trivial topic in many programming languages, like we are here doing a constant assignment. But in Ruby, they are a very rich topic with a lot of edge cases and stuff. And the main reason is that Ruby does not have syntax for classes and modules. So when we do this, we are doing a constant assignment. So we think, in our day-to-day, we think in terms of, when we see that capital C, we think in terms of classes, all right? But in reality, technically, that's a constant. That's a constant. So that's the same thing as doing this. you instantiate a class object that is stored in the C constant. So constants are storage, like variables. They are storage. They are like this X storing a 1. There's no difference. This C is storing a class object. This guy is storing an integer object. This one is storing a class object. That's it. And from here on, constants and class and module objects are independent. You can remove this constant. You can store the class object in a variable. But they are absolutely orthogonal. And that's what makes this topic like not trivial in Ruby. So for instance, here we have user.new. We think here in terms of classes and modules, but in reality, what happens is that user is a constant. That's an expression. It evaluates to a class object, and that object responds to the new method. The return value of the new method is your user instance. Similarly, in date, you have to think that's a constant. Forget about classes. That's a constant. Evaluates to a class object. That class object responds to today. The return value of that method call is a date object that we store in the today variable. Okay? So in our day today, we talk about the string class, and we write a string. That's built in the interpreter. It is already in memory when we boot. But a string is not special at all. It's just a regular constant like x equals 1, okay? Constants belong to modules. So every class and module, you have to think that it has like a symbol table. It has like a hash table of constant names mapped to the values. That's like literally that way. So every class and module in your system has this little collection associated to it that stores the constants. So when we do this thing, class hotel, and inside that module pricing, class hotel defines a constant in which class or module in object. So the top level namespace is object. I am going to use the word namespace. Namespace is not a formal concept in Ruby, but since we are working on the hypothesis that there is a project structure, we can work with a convention, and we know what we mean when we say namespace in this context. Okay, so the namespace for hotel, where is hotel stored? The constant is stored in object. Okay, so hotel is a constant that has a class object inside, and it's stored in that collection of the object of object. Module pricing is a constant that is going to be defined in the symbol table of the class stored in the hotel constant. Okay, so the main characters here are class and module objects. Constants are storage. Is the module or the class object in this case within the hotel constant that is storing the pricing constant, whose associated value is a module object. Okay? That's the way it works. We can alternatively, we have this alternative syntax. In this case, hotel has to be already defined, as you know, okay? And we are defining or reopening a pricing constant within the class that is stored in the hotel constant. Okay, that's the full thing. And in this presentation in the day-to-day, you do not work maybe that way. We do not think, with this precision. But for this presentation is important. All right. So we are going to see very quickly. It's not going to be reference. Just a reminder of how constants are resolved in Ruby. We have this concept of nesting, which is lexical. Basically, the idea is every time you use the class or module keyword, you are nesting the class or module objects respectively into an internal collection that the interpreter maintains. That's not visible. You can inspect it, but it's just a lexical concept. Call it nesting. So this works? Doesn't seem to. Okay. So in the first comment, in that line, the nesting is formed by those two things. Hotel : pricing, which is a module object. We see the constant and we think constant, but that's module object. It's just one single instance, all right? And hotel, which is the hotel class, okay? That's the nesting. Observe that object is not part of the nesting, okay? So you only push things to the nesting when you use the class and module keyword. There are other ways to do it, but they are more obscure, not needed for this presentation. It is very interesting, very relevant to constant resolution, that in the second case, where we use the fully qualified name, let's say, the nesting, we are only using one module keyword, right? So that module keyword is pushing that module to the nesting. That's it. So hotel pricing is in the nesting in both places, but hotel is not. So when the resolution algorithms that we are going to see now look for the constants in the classes or modules, it's very important to understand that in the first case, the constant, if it's in the place of that comment, is going to be checked in hotel pricing and also in hotel. Whereas in the second case, it is not going to be checked in hotel because hotel does not belong to the nesting. This is very important to understand. Then we have the concept of ancestors of a class or module that you all know. That is the ancestor chain that we use to resolve methods, you know. This is an example with a string, okay? You can inspect that as well. All right, so very quickly, just to have an idea, how do we resolve relative constants? So in this case, we think ERB, for instance, in the example, okay? So easy. You are when you see the constant, you are in a certain place in the listing, right? Like you see it, okay. So then the algorithm goes first outwards, following the nesting from inside to outside. So first you go the diagonal. If the constant is not found, then you go back and go the ancestors up, all right? Diagonal first, ancestors then. Object is checked later if you are in a module, because object does not belong to the nesting and does not belong to ancestors of modules. So if you use, for instance, the hash constant, okay, inside a listing, first Ruby checks the nesting. Even if you think hash, this is like hash, okay, the global thing, it becomes built in. It is just a regular thing. So hash goes first to the nesting, then the ancestors, and if you are in a module, it has to check object, which is where hash is stored. So it goes all this way until it finds hash, all right? Finally, if the constant is not found, there's a callback called const missing that is going to be called. There's a default implementation of const missing, which is the one that raises name error, all right? But you can override this. Then, if you have a qualified constant like rack request here, this is much easier. So in rack request, we have like rack, the first segment, that's a relative constant. So rack is going to be resolved with the previous algorithm. Okay, that's relative. But request is qualified, and request is the one that is solved using this algorithm, which is much easier. It just checks the ancestors of rack upwards, and well, there's a technicality here for object, doesn't matter, and if it is not found, const missing. So this is easier, all right? And this does not take the nesting into account, all right? Okay, so how does Rails autoload know that we know this? You know that in Rails, there's this concept of autoload paths that by default has everything in APP. APP models is in autoload paths. And the autoload path represents object, represents the top-level namespace, okay? And then Rails defines a const missing hook. So when a constant is not found, that's autoloading, right? The constant is not found, is unknown at some place. Const missing is called. So Rails knows that the constant with this name, which is a string, it was not found while I was in this class or module. Then Rails goes to the autoload paths and sees if, well, it has to underscore the constant name, okay? So you got user, capital U, you underscore that, user, and it walks the autoload paths looking for user.rb, right? If it finds it, it loads it, and the execution resumes. All right, that's the basic idea. There are many lines of code in dependencies, but the basic idea is that. So the problem with that is that the technique itself has some intrinsic limitations. All right, so this autoloading has been very helpful. We have been able to work with our writing requires all these years. So this was a feature that I loved about Rails. And it's that kind of feature that it's working for you, and if everything is going well, you do not even notice. It is just there. It's doing its work, you do not even notice. But when it does not work, sometimes it's difficult to understand why. There's documentation, but there are some gotchas. So why it is limited? Well, in const missing, you get the constant name and the class or module where this was not found. Which is the nesting at that point? You do not know. It is not in the API or const missing. Was the constant missed in a relative or qualified context? You do not know. So active support just does not have the information to resolve the constant the way Ruby resolves constants. So the semantics do not match. It does the best that it can, and it has some assumptions, like I'm going to assume that the name of the module is reflecting the nesting. It does, some reasonable assumptions, but it just cannot solve this problem. There's no information. Then another one is that const missing is the last step in the case of in both cases is the last step in the resolution algorithm, and that also by itself, even if you had these first bits of data, the third one is still a problem, and we are going to see now why. And finally, it's not thread safe. Rails has had to work around that with internal logs and stuff. All right. So const missing is the last step. Why is that a problem? Because let's suppose that you have a hotel class with module pricing, okay, that you have defined in this second file, and your intention in the first file is to load your own pricing, okay, the one scoped to hotel, right? That's the intention. But let's imagine that hotel pricing is not loaded, but you have a pricing at the top level loaded because of the code path. That happens in development. That can happen in development. Well, that can happen technically in any mode. What happens? It happens that since Ruby is able to find a pricing constant somewhere, it is just not going to call const missing. It found something. It returns done. All right, and you get a class or module object that is what it is not the one that you expected. So fundamentally limited. It's a technique that is fundamentally limited. So Zeitwerk uses a different technique. It is based in module autoload. Maybe you know module autoload. This is the Ruby autoload thing, all right? So you can, in active record, for instance, this is used a lot in the Rails code base. You can say, I'm going to lazily load base, basically, active record base, okay? So instead of loading everything, you can say, whenever you need active record base, go and fetch, please, that file, all right? That's the idea. So the new approach, the idea is the following. You have also the autoload paths, which are which represent the root namespace object. And then let's forget about namespaces for a moment, just to understand the technique. You have the autoload paths, okay? So for instance, you have app models. So when you do setup, you go to app models, and Zeitwerk goes to app models and lists the directory. If it finds user.rb, it sets an autoload call in object to autoload user. And it does that for every entry in the directory. Okay, that's the basic idea. Then namespaces complicate this a little bit, and the API is bigger, and there's more things that it can do. But that's the idea, all right? Nevertheless, I have had this idea for years, and there were some technical difficulties. And it was in October of last year that there was a new issue about autoloading in Rails, and I was like, okay, I'm going to work on this. I don't know how I'm going to solve it. I know the technique that I want to use, and I know that I have some roadblocks, but we will get it. Okay. So, technical difficulties. A module autoload uses require internally. So this does not work well with reloading, because require, you know, if you require is idempotent. That's it. That's the thing. Okay. So there is no API to remove autoloads, and if you are reloading and you had an autoload that had not been executed, to make things clean, you should remove that autoload. Otherwise, you could have unexpected loadings in the next request. Does not support namespaces, so you can say autoload one simple constant name. You cannot put a qualified constant name in autoload. You cannot say in object autoload admin : users controller. You cannot do that. You need the class or module object, the instance, and set an autoload for that instance for the next level, okay? And finally, there's a chicken and egg problem with explicit namespaces that I am going to explain right now. So, all of this is solved. Require, idempotent. So it has been a goal of the project to stick with Ruby standard APIs and to stick with Ruby semantics. That's like a goal of the project. So the project needs a few hacks, but they are very controlled, and they are not like crazy. For instance, this is the first one. How does require know if it already loaded user or not? It knows because there's a global collection called loaded features that remembers everything. So require goes to that collection and says, do I have this user thing? If it's present, then it does nothing and returns false. If it is not present, then it goes and requires the file and stores the file name in this loaded features collection. So the collection is mutable, and we just remove the string from the collection and done. So it's this level of hackiness. It's not like crazy, all right? Then there's no API to remove an autoload, but constants that have an autoload, semantically for Ruby, they are not very different from regular constants that are already loaded. And it turns out that if you remove const, the autoload is gone. So solved. Then namespaces. We cannot put a qualifier name, right? So this is another little hack. In the case of implicit namespaces, we set an autoload on a directory, which is not documented. It's not a standard use case of autoloading, but it works. So, so we set an autoload an object on admin. And then there's a very thin wrapper around kernel require. Kernel require until 2.3, I believe, was not used by autoload. So when we say autoload uses require, until 2.3, it was an internal require, different from kernel require, and you couldn't access to that require. That was a roadblock for implementing this. But this changed. So we have a very thin wrapper around require, nothing crazy, just very thin, and we intercept. We know the directories we are watching, we intercept. And if you pass a directory to that require, it doesn't delegate to the actual kernel require. Intercepts that, goes, defines the dummy module for you, and does one step. It goes, since it has already the module object, then it can go to that directory or different directories, because the namespace can be split in different directories, and does one level more. That's one interesting observation, that Zeitwerk in autoloading mode is as lazy as possible. So it's going to do only one level of dev at a time. And it is not going to descend on subdirectories unless you use them, all right? Then the chicken and egg problem, this was the last difficulty, and I didn't solve this. I copied this from a gem from Shopify. And so the problem here is you have an explicit namespace like hotel that wants to use one of his modules, okay? Then you have the module defined below, right? The problem here is that in order to evaluate the first file, you need pricing. But in order to evaluate pricing, you need hotel. So what do you do here? The solution has been trace point. So we set the trace point on the class event. This has to be a cheap thing. And Shopify has Zeitwerk in production, so no problem. This is this is just an event that is triggered when classes are created or reopened, modules as well, of course. Then the thing is that thanks to the trace point, we are called. So so hotel is evaluated because you are using the hotel class somehow, and then after the class keyword, before the include line, you are called. So we are on time to go and descend at that moment into the hotel subdirectory and put the autoloads, and then the next line pricing works. That was the trick. So with that, everything is solved, and the gem is published. All right, some final slides to explain a little bit, just a few ideas about the integration in Rails 6. This is enabled by default in Rails 6 new applications, all right? It has to be in C-Ruby. JRuby, they're working on that, but for instance, JRuby still has an internal require for autoload. So they're working on that. They're working on that. So to be precise, is Rails 6 by default if you are in C-Ruby. All right. So if you have this in config application.rb, load default 6.0, done. That it's already integrated for you. Then I'm very happy to tell you that you can remove all required dependencies. Done. So required dependencies is going to be part of the history, and you do not need this anymore. And if you are upgrading a Rails application, in principle, you should just remove required dependencies, and it should work, right? Okay. It could be the case that you need to tweak a little bit the inflector. In the case of Rails, the inflector is active support, okay? In the case of the default inflector that comes with Zeitwerk, it's a trivial thing that does like a split, you know, a one-liner that is super deterministic, no problem, there's no configuration, that is deterministic, is under your control. But in Rails, the natural inflector for Rails is active support caramelize. And you may need to tweak the inflector because the classic autoloader receives the constant name and goes to the file system, okay, with underscore. But Zeitwerk goes the other way around. Zeitwerk first visits the file system, and then infers which should be the constant defined in those files. That's caramelize. That's going the other way around, okay? So these operations are not inverse of each other, all right? So the capital letters HTML underscore gives you HTML all lower score. But if you go the other way around, you do not retrieve the same value. They are not inverse of each other, and they maybe for some acronym, maybe you need something, but in general it should work because we are using the same convention that Rails already uses. But anyway, recently I implemented this little check that you can run in your project if you're upgrading, okay? You upgrade to Rails 6, and before enabling the default, you can, if you want, run this check, and it's going to detect files that are not defining the constant that are expected. Then you can go, okay, I need an acronym here. I'm going to go to the inflector. Or you can even define your own inflector. Okay, you can do that. Okay, a configuration that is not in the release candidate, it was pushed after the release candidate, but it's going to be in final, is that Zeitwerk internally has a rule there are several rules in the project. One of them is that it is forbidden to do walk paths. Forbidden. Zeitwerk systematically uses only absolute file names internally. So there's no need for require, there's no need for require dependency, and Zeitwerk only uses absolute file names internally. So there's no need to have the autoload paths in load path. The load path is the collection that Ruby uses to resolve relative requires, right? So no need. So I don't know if you were aware of that, but APP models, APP controllers, APP helpers, they are in autoload paths. They are also in the load path, but we do not need that. So you can opt out. By default, it's enabled because it has been there, that way since the beginning. So, but you can opt out. So with that, you may save some hops in the resolution of relative requires by Ruby itself. And if you are using Bootstrap, opting out of this saves also Bootstrap work because it does not have to go to all those directories. It does not have to walk your project structure, and also saves memory because it doesn't need to build an index for all those files. Okay, so that's an interesting flag to take into account. Finally, you can opt out. If you are upgrading and you say, okay, I have a lot of work to do, we are going to deal with autoloading later, you can just say config autoloader classic, and you are using exactly the same autoloader that you were using in your previous version. And finally, there's going to be, now that things have settled and the API has converged, there's going to be documentation, of course, in the upgrading guide, and there's going to be a new constants guide covering Zeitwerk. All right, that's it. Thank you.